Hello guys, this is your 3-6 video on using perpendicular lines. So the first two ideas, I need you to understand that distance is always a perpendicular distance. They won't tell you that, but you need to understand that it's always a perpendicular distance. It's not going to be a wavy line like a toddler would do going through a store. It would also is not going to be any random line. It has to be perpendicular. Now you already know that distance has to be positive. We learned that before. Today, like I said, very important that you understand that it's a perpendicular line. So the first one says from a point to a line, it's the length of the perpendicular line from the point to the line. And you'll see that in an example in just a few minutes. The second one says the distance between two parallel lines is the length of the perpendicular segment joining the lines. So again, it has to be perpendicular. So if you bear with me, I'm going to show you some examples. This is what you picked up after your quiz. I want to go over each of these examples with you. So the first example says, find the distance between the two parallel lines. Well, the first thing we need to do is decide where that perpendicular line is. Please do not guess. Do not just randomly connect this point to this point or this point to this point. You have to use what you've already learned, which is the perpendicular slope. So if you look at these two lines, use any 2 points and we know that they're parallel. So if we start here, we can count down to right 5. So down to right 5, which means the slope of those two parallel lines is -2/5. Down means negative. So if we use our perpendicular slope would be 5/2. The given distance is -2/5. The perpendicular slope is 5/2. That's how we figure out where to connect these two dots. We're going to use the perpendicular slope, which is 5/2. That means up 5, right 2. You can start at any of these points. I know from algebra that this means up 5, right 2. If I start here, I'm going to go off my page. If I start here or here, I'll probably be okay. So what I did on my example, I counted up 5, right 2, made a dot. Up 5, right 2, and that's where they connect. This is the perpendicular line that I'm going to find the distance of. You guys should know your distance formula. If you do not know it, there it is there. You need to memorize that if you don't remember it. So I find the distance between these 2 points. This point is -1,6 and this point is -5,4. I plug that into the distance formula. Remember, you subtract your x's and square it, subtract your y's and square it, add them together, and then square root. In this case, we are not doing simplest radical form. We're going to plug it into Desmos and round to the tens place. So again, biggest thing is to understand perpendicular distance. Use your perpendicular slope to figure out what gets connected. It is possible to have two different points and still get the same answer. So if I started here and I went up 5, right 2, up 5, right 2, these two can also be connected. And using those endpoints, you will still get the same distance. Do not just guess. You have to use your perpendicular distance. Going on to the next example, I'm not sure why the lines didn't show when I got it copied, but this is a very similar example. You're finding the distance between the two parallel lines. So if you take a second and draw those two lines for me, I would appreciate it. First thing you're going to do is look at the slope of these lines. If you count to figure out what the slope is, it's the fastest and easiest way to do it. It's up 3, right 3, up 3, right 3. You can pick any 2 points on those lines to figure out what the slope is. 3/3 simplifies to 1. Perpendicular slope is going to be -1. Remember, you're flipping it and changing the sign. So using that perpendicular distance, we're going to go down 1, right 1, down 1, right 1 to figure out where those dots connect. Again, this is not the only place you can connect them. I would always start with a dot or a point and go down 1, right 1. In this case, I used -1,6, which is here, and -3,4, which is here. Plug those 2 points into the distance formula, and again, plugging it into Desmos and rounding to the tens place, I got 2.8. The last one is a little bit different. It says find the distance from the point to the line. So in this case, you don't have many choices. You have to start at this point and figure out where that perpendicular line is so you can find the distance from here to somewhere on this line. So same idea, I'm gonna figure out what the slope is of that line. In this case, it goes down 1, right 5, which means -1/5. So a slope of -1/5, the perpendicular slope, you flip it and change the sign, your perpendicular slope is 5. So going back, well, let's do it this way. So I'm using the perpendicular slope, which is 5, which means up 5, right 1. When I start here, up 5, right 1 connects here. This is the only possible distance. You're not gonna go this way, you're not gonna go this way, you're not gonna do some kind of curvy thing. It always has to be perpendicular. So those 2 points that you used is -2,1 and -1,6. Plug those into the distance formula. If you're not comfortable with the distance formula, please ask me for help. Do a Google search, watch a video. Please make sure you understand the distance formula because it's important in this case. There's one more example I want to go over with you. This is the one that's on the board. So it says RS is perpendicular to ST, find the value of X. So I'm going to flip back to where I have it done. So in this case, you have to remember that because this right here is 90 degrees, the other side's also going to be 90 degrees. So these two angles together are going to form 90 degrees. This one and this one are vertical. If you look for this X here, these are vertical angles. This one and this one are vertical, which means they have the same angle. Because they have the same, I can say 2x plus 8 plus 3x plus 7 equals 90. And that's what, mine's a little bit similar. I ended up using this entire line. So I said 2x plus 8 plus 3x plus 7 plus 90 equals 180. It's still the same idea. So when you solve it, you find x equals 15. You can do this in either way. They're both correct. So there's your homework. You do not have to do the page 203, just the 195 to 196, and you do not need graph paper. Remember, next time I see you, your project is due. Please have that ready to be submitted the morning of Friday.